All right, we're doing chapter 6, lesson 3 today. We're solving equations with rational coefficients. Before we begin anything, who can tell me what a coefficient is? This is a word that you guys have had this chapter. Okay, remember, you guys got to earn your participation. V.
It's the number that is with the variable.
Okay, so it's a number in front of a variable. What does that mean? What does this mean that I wrote on the board? Brody.
2 is being multiplied by x.
This means 2 times x. There's 2 x's. So let's recall on the stuff you guys have already learned. 2x plus 3y plus 5x. How do I simplify this expression? Use correct terminology. Brody, I just called on you. We gotta get somebody else in. Delilah. Ooh, we're close. Not similar variables. What are they called? There's another 2 words for it. Neither one of those are the same ones. Give you the initials. LT. Oh, there we go. She got it. You guys keep doing this like she's not gonna get it. I'm not saying you rose it higher so it blocked her face. So, okay. So we're gonna combine like terms. Who can give me the definition of like terms? She kind of did. Oh, remember, you guys want to earn your participation. Zorwar. Aw. Never mind. You don't know it? What's the definition of like terms? Terms that have... There you go. So terms that have the same variable are like terms. So 2x and 5x are like terms. 3y does not have a like term here, does it? Okay, so what is my written simplified expression, ladies and gentlemen? Okay. Everybody again, I said ladies and gentlemen, ready, go. Remember, why did I put 7x first before 3y? Why wasn't it 3y plus 7x? Who can recall? Elbow. Goes in alphabetical order, so it has to be 7x plus 3y. Does it really matter, though, if it's 3y plus 7x? Why does it not matter in this case? Wait. In this case, why does it not matter? So, which states? There we go. So technically, this is just appropriate, but if you were to write 3y plus 7x, I would not mark this wrong. It's just kind of like an OCD thing. It needs to be in alphabetical order for it to be nice and appropriate. So it's still not wrong, but, semantics. So we know what a coefficient is. We know what a variable is. We went over like terms. Commutative property even snuck in there. So we reviewed. Now let's get into what we're dealing with now. Today we're dealing with coefficients that are not whole numbers. So meaning we're dealing with what, ladies and gentlemen? And we're going to be dealing with fractions as coefficients and decimals as coefficients. You don't need to write those down. I'm just giving you examples. So this is where things are going to get tricky because now we're going to not just move a whole number. Because remember, if I have this, I'll give you this example. 2x equals 14. How do I solve for x? What's the most important rule of solving for a variable, ladies and gentlemen? We need to, I said ladies and gentlemen. We need to isolate the variable. What's happening to the variable right now, ladies and gentlemen? So what do I need to do to get that by itself? Now I didn't say, ladies and gentlemen. Now I'm calling on people. Ooh, same hands. Izzy, I know you know this. What do I need to do to get that x by itself? What's happening to the x right now? It's being multiplied. So how do I undo that? Why am I choosing division? Aubrey, what is that known as when we do the opposite operation? It's the what? Again, you guys raise your hands like you have no faith. No, put your hand down. Aubrey, talk to your group really quick. Help her out. Somebody knows. Help her out. What does it mean? What is it called if I use the opposite operation to undo it? Inverse operation. So I divide this side by 2 to undo it. I have to do the same to the, ladies and gentlemen. Okay, so this becomes x equals 14 divided by 2, which means x equals... I didn't say ladies and gentlemen. Now I am saying ladies and gentlemen. Equals 7. Now we're going to do this exact same thing, but now we have decimals and fractions. And this is where we're going to do a lot of review. So we're going to skip a lot of this because we kind of covered this. This is the one I want to do first. 15C. Some of you guys already looked at this and went, don't psych yourselves out. You guys know how to do this. 15C equals 3/4. Now, let's get some people who have not talked yet to walk us through this because we know how to do this. Group members, look at that person at your group that has not talked yet. If you're the whole group, just stare at each other. Dominic, what's my very first step here? What do I need to do first? Okay. How do I do that, Maddie? What is the variable, Maddie? What's happening to C? By what number? So how do I undo that, Cody? Being multiplied by 15. How do I undo that? Divide it by what? Okay. Jaylene, if I divide that side by 15, what do I need to do the other side? Group, help her out. What do I need to do? Jaylene, remember? The equal sign is a what? We talked about this. The equal sign acts like a... Jaylene's got this. She's been here. It acts like a what? What do you always pull out in class? Not the hairbrush. It's a mirror, okay? So if I do, so if you look in a mirror, Jaylene, you raise your hand in the mirror, doesn't your reflection do the same thing? So if I have divide 15 on this side, what do I need? There we go. What? I have to do the same thing to the other side. This is where the review comes in. With your group, let's see if you guys remember this. This is stuff you guys learned last year, right? How? No, we did this year too. How can I solve this? No. I said with your group. I'm going to pause this for Tyler. Okay. So, what is the very first rule when we divide by fractions? Both numbers have to be fractions. That 15 is a whole number. How do I make that into a fraction, ladies and gentlemen? Put it over 1. Okay, so 15 needs to go over 1. Guys, this is a live mic, so it's catching you guys. Focus. Okay, now what's my next step? I'm going to change the colors here. Ladies and gentlemen, what's the rule? Ooh, not yet. Say it nice and loud. Keep. So the first fraction stays the same. I'm going to move it over here. Keep. That means the division symbol becomes what, ladies and gentlemen? And we flip the other one. That is known as its, ladies and gentlemen, that's known as the what? Someone said it. That's the reciprocal. When you flip a fraction, it's known as its reciprocal. Now I can multiply, but there's something I need to do first. Gerline, now what is it? Check for cross simplification. If you don't do this first, that's fine. It just makes your work a little harder later on. So what two numbers here have the same factors? Remember, we look for them diagonally. So 1 and 4, can I simplify them? Why? Ooh. Delilah. They technically do. Yeah, they do. But you can't simplify one, can you? So remember, if any of them is 1, not going to simplify. And then 3 and 15, they have common factors. What are they, ladies and gentlemen? Every class yelled 5 today. Can 5 go into 3? Matthew, remember, it's the number, common factors, number that can go into each of them. So Matthew, what common factors do they have? What common factors do 3 and 15 have? 3. So if I divide each one by 3, 3 divided by 3 becomes, and 15 divided by 3 becomes, okay, now I can multiply straight across. 1 times 1 equals? And 4 times 5 equals? That's it. Now, hang on. Okay, you guys are competing with the other classes and you're not doing well. Let's do this not with cross simplification so I can show you guys how this would be. What's 3 times 1? And what's 4 times 15? Okay, now you have to simplify this. What do they both have in common? And that would be simplified down to? So again, you don't have to cross simplify, but guess what? When you have different numbers that are not easy to multiply, you have a higher chance of making a mistake. So that's why you check for cross simplification, because you're dealing with smaller numbers that you know how to divide and do that. So it's easier math when you do the cross simplification. Otherwise, you may run into a part where you either forget to simplify and then you get the wrong answer, or you multiply wrong and you get the wrong answer. So a lot easier just to do, these both have 3 in common, that's 1, that's 5, and now you guys can all do 1 times 1, which is, and 4 times 5, which is, so easier math. And of course, this is all algebraic, so C equals 1 over 20 to make this correct. Yes?
If we didn't inverse it, so say like, if we didn't use inverse operations, wouldn't it just be a whole number? Because then it'd be 1 over, or something over 1.
So go back to the original. Hang on. Let me erase all of this.
Operations, right? So it's 3 times 15, oh, never mind.
No. Just remember, this is saying, I'm going to erase a lot of this work. This is saying 15 times what would make it 3/4. And when you plug in 1/20, 15 over 1, this will become 15. Actually, let's do this. Watch. Let's check our work. 15 over 1 times, and we said it was 1/20, correct? Okay. What am I going to do first? What do you guys want to do? Yeah, let's do cross simplification. 15 and 20 have what in common? So if I divide these both, 20 would become what? 20 divided by 5 is 4. So this would become 3/4, which is correct. So we did it right. Okay, now we have one more review that we need to do, because now we're going to be dealing with decimals. So we have 0.75. 0.75 C equals 15. Okay, so quick review. What's my variable? Rapid fire, everybody. What's my variable? C. What's happening to C? By. So to undo this, I'm going to by on both sides. Okay. So again, we need to isolate the variable. We divide that. And now we have ourselves a situation where I have 15 divided by 0.75. So I'm going to show you guys how to write this as a division problem. 15 divided by 0.75. Now with your group, again, just like last time, you guys should know how to do this. This was last year's work. I know we didn't touch on this year. How can I do this? I don't want you guys to solve it. I just want you to talk to your group and see if you guys can recall. I can't divide right now. I'm telling you guys right now, I cannot divide. With your group, explain what are the steps we need to do, and then when can we divide, and then you guys will divide later. Right now, I just want you and your group to talk about the rules and figure out what we need to do. All right, so a lot of us had the right idea. What's my very first step? Why twice, though? Okay, so very first step is don't use the numbers. We need to move the decimal all the way to the right to make it a, ladies and gentlemen, whole number. So don't get with the 2 times, because some people may see it and then only move it twice when you need to move it 3 or 5 times. So you need to move the decimal all the way to the right because this number needs to be a whole number. That number, 0.75, is known as our what? Vocab. What is that number? The outside numbers. That's the number we are dividing by. It's known as our divisor. The inside number is our then, ladies and gentlemen? Dividend. The divisor, this should be in our notes. Brody. The divisor has to be a whole number in order for us to divide. The reason why, a lot of groups did not get this, the reason why is because, remember, you're putting this inside of this number, and I can't do that if it's a decimal, right? So it's got to be a whole number. So the divisor has to be a whole number in order for us to divide. Now, there's a second step. We jumped the decimal twice to the right, all the way to the right, to make it a whole number. But there's a reason why we count how many jumps. Why did we count how many jumps, and what do we need to do now? Rowan. Zorwar.
You have to kind of like with like the other ones. It's like a mirror, so you have to do it on both sides.
Okay, so 15 doesn't have a decimal, though. Does it? Where is it?
It's behind.
Why is it behind it?
Because it's a whole number like that.
So, decimal does exist. It's just hidden. It's behind it. Since the outside moved twice, so I have to do the same thing on the. But if I move this twice, what happens? I didn't say ladies and gentlemen. Brody. Not add zeros. We need to, ladies and gentlemen, annex zeros. Okay, the decimal's here, and then there's one last part I need to do. What happens now? There's no more tissues because you guys use them all. Sorry. You guys gotta start bringing tissues. Okay, what's my last step? Phone? What is it? Okay. What's my last step? I moved the decimal, and now I have to do what with it? Bring it up. Okay. I helped you guys set it up. You guys are going to solve it. No calculators. This is easy. Okay, work with your group. Go. I already told you, give you a heads up. Maddie, what did we do first? Why didn't we go to 1? What about 15? Can't go into 15 either? Okay. So we're going with 150. 75 goes into 150. And that equals what? Okay, now I've got this weird conundrum where that's 0, but I have this extra 0. What do I do with that extra 0, ladies and gentlemen? Bring it up. So it's 20. So going back to the original problem, C equals 20. And let's check our work and see if this is right. Calculator. Remember, calculators are not for solving the problems, they're for checking the work. 0.75 times 20 should equal 15. And it does. That group. All right, and then we have a few things we need to go over. Okay, first thing, decimal coefficients. This needs to be in your notes. If the coefficient is a decimal, divide each side by the coefficient. Pretty simple. So again, when you have a decimal, you divide it each side by a decimal to undo it, and then you guys know the rules of dividing by decimals. Remember, if the divisor is a decimal, it needs to be a whole number. What happens if the divisor is already a whole number? What do we do?
They don't do anything.
Well, what about the inside? What if the inside number, the dividend, is a decimal? What do I do? What do I do with the decimal? Say it nice and loud. Okay, let me give you guys an example. So, let's say I have 10.81 divided by 7. 7, the outside number, the divisor is already a whole number, right? So what do I do with the decimal on the inside, ladies and gentlemen? If If I didn't have to do anything with the decimal on the outside because it's already a whole number, what do I do with the decimal on the inside? Just bring it up in your answer and then divide normally. That's it. So back to vocab. If a coefficient is a decimal, divide each side by the coefficient. Okay, now we're going to review one thing before we go into the next thing. What happens if I have negatives? So we're going to do this example really quickly. The example is negative 4.7k equals negative 10.81. That's where the 10.81 came from. So same setup as last time, but now I have negatives involved. So I'm going to divide this side by negative 4.7 and this side by negative 4.7, right? This will cancel out. But what is my answer going to be? K has to be what, ladies and gentlemen? It has to be what? Someone said it over here. K has to be what, ladies and gentlemen? Positive or negative? Positive, because remember, a negative divided by a negative will be positive. So that's the other rule you need to remember. So then I would do this, set it up the same way as last time, and we would divide. We're not going to do that in this example, but I'm just saying, remember with the negatives and the positives, if one number is a negative, one number is a positive, your answer is going to be negative. If both numbers are negative, your answer should be. And if both numbers are positive, your answer should be. Okay. And then we're going to do one other vocab term for today, and that is fraction coefficients. You're going to want to write this word for word in your notes, but I'm going to explain what it means in kid speak because that first sentence sucks. Recall that two numbers with a product of 1 are called multiplicative inverses or reciprocals. Basically, what that sentence means is this. Say you have a fraction and you multiply it by its reciprocal. My answer will always be what? Ladies and gentlemen, what will my answer be? 1. No matter what. So again, listen to the words I'm saying. If you take a fraction and you multiply it by its inverse, the answer will always be 1. These two here are known as their multiplicative inverses. It's right there, multiplicative inverse. So if you multiply a fraction by its reciprocal or its inverse, it is known as multiplicative inverses. The answer will always be 1. So back to the definition. If the coefficient in a multiplication equation is a fraction, multiply each side by the reciprocal of the coefficient. That's just saying that when you divide by a fraction, you actually end up turning it into multiplication and multiply it by the reciprocal. So you don't have to show me the keep, switch, flip every time. So an example of this would be, let's say it's 1/2 x equals 6, right? Instead of me dividing by 1/2 and then dividing this side by 1/2, this would just become times 2/1. Because I'm already flipping it. I'm already doing the keep, switch, flip anyway. 6 needs to be over 1. 1/2 becomes 2/1. I multiply straight across. That's 12/1 or just 12. X has to equal 12. So you don't have to set it up with the keep, switch, flip every single time. You can literally just take the reciprocal and multiply. And then that's the lesson. That's it. That's the whole lesson. Your homework is all 21 questions. It's due by the end of the period tomorrow. I highly suggest you start working on it today and do some for homework, because if it's not done by the end of the period, it is not getting these 21 questions. Yep, and I'm going to stop the recording.